All of you are welcome, and today we discuss about the continuation of engineering chemistry lecture series, in which the video lecture itself is there. And so, I want to explain the alkali metals. Alkali metals. What are the first of all? We have the concern about the metals. Different metals are used in the different types of technologies, and number of metals are reactive and number of metals are passive in the nature. Very well known whatever the iron age. In case of the iron age, there is the involvement of iron and its alloys. So iron was used for the different activities of human being, and so that particular iron age was there. Then we have to see different civilization areas were there, including the Stone Age. So whatever the question is there, we back to the civilization. So therefore, certainly their involvement of the different technology. Metallurgy, the iron metallurgy, that is also relevant with the various technologies, and therefore we have one of the concern, that is the alkali metals. So what are the alkali metals? We can define these alkali metals, and then we have to see that the name is there, the alkali itself. So sodium hydroxide, that sodium hydroxide, is the alkali example of the alkalis. So whatever the nature of alkalis when regards with the acidity and basicity, these are the bases. So sodium hydroxide itself is the base, that is the alkalis. So alkali metals are that relevance with the alkaline characters of those. If we have to see the lithium hydroxide, potassium hydroxide, sodium hydroxide. So the name of sodium hydroxide itself is caustic soda. So caustic soda, this is also useful in different technologies, as well as we have to see the caustic potash. So caustic potash is the potassium hydroxide. Whatever the relationship of these alkali metals with other uh, anions, for example, carbonate. So carbonate combined with the sodium. So one of the important compound, sodium carbonate, is formed, and all of you have known about the sodium carbonate. Sodium carbonate is the washing soda, and which is used earlier ago, and whatever that particular washing soda is used for the washing of the clothes for the cleaning purposes. So here the question is there, the role of alkali metal compounds in various areas, and there is the significance. Potassium hydroxide, that is the caustic, potash, so that is also important concern, potassium carbonate, potassium sulfate, calcium, so sodium sulfate, sodium bicarbonate is one of the relevant to our cells, and that is the baking, uh, whatever that baking soda. So baking soda, sodium bicarbonate. So how they form such a number of compounds with the alkali metals. So before going to the alkali metal, we have to discuss one of the most important concern, and that is the periodic table. And in case of the periodic table, where alkali metals are there. So where are the alkali metals? Present in a systematic arrangement of the elements, and that is the periodic table, modern periodic table. So modern periodic table, this one is related with uh, the atomic numbers. So arrangement of atomic numbers are relevant for that purpose. So we have to see the arrangement of atomic numbers. So all of you are well known about what is the atomic number. So in periodic table, we have the systematic arrangement of the elements, and the systematic arrangement, and that is in the form of their electronic configuration. So we have to see the most important concern of the alkali metal because they are in group number 1. Why they are in group number 1? Whereas whole periodic table is divided into the 18 1 18 groups. So the group number 1 according to modern periodic table, group number 1 is the alkali metal. Here, the configuration, electronic configuration. So, what about the electronic configuration of alkali metal? Anyone? What is here? The electronic configuration of alkali metal itself is Ns1. So, N represents the shell number. Which one? The outer shell. So, here whatever it suppose we have the periodic number of periods, period number 1, period number 2, period number 3, period number 4. Period number 1, hydrogen. So that is the electronic configuration is 1s1. Then period number 2, we get the lithium. So lithium present in the period number 2, where the electronic configuration of lithium is 1s2 in a first shell, the second shell, because that is present in the second period. So here 2s1. So only one electron is present in s atomic orbital. So spherical, whatever that represents the s orbitals. So here when we have the all of you have know about the quantum numbers. I have also one of the video lecture that is related with the quantum numbers. What do you mean by the quantum number or in an atom that can relates? What is the relationship with the electrons? Because of the quantum numbers are the number and which specify the position, whatever that is the different task. But we want to, where is the proton, the electron? So that particular the identification of electron. If suppose we have to see in our campus, we can identify that particular lecture theater is where. So how we can identify? Whether we can say the arrows are there and we enter into the campus and find out the lecture theater number 22. How we can identify that particular? So similarly, in an atom, for example, potassium. So potassium itself is one of the example of alkali metal. So in case of the potassium, how we can say that particular 17 electron is where the position, whatever the position we can say, where is the 17 protein electron present in the potassium potassium metal. Potassium metal, this is one of the example of alkali metal. So where is that particular 17 electron? So how we can say that is because of the quantum number. So quantum number expresses where each electron, which electron is where, and all of you well known. The quantum number represents their the shell, whatever the shell number, that is the period number 3. So in that particular case, the shell number is the 3. Period number 4, the shell number is 4. So in case of the potassium, electronic configuration, when we have to see the electronic configuration of potassium, 19 electrons are there and they are arranged, 19 electrons are arranged in a potassium. When we have to find out here that the last electron represents, that is present only one electron in outer shell. So what we have? So is there any specific characters of those potassium? Potassium itself is one of the reactive metal, and easily uh, this can lose one of the electron. That is the characteristics of alkali metals. So therefore, the quantum number of the electrons, they represent their the situation where in the which cell they present, the shell number 3, they present the 17th electron of 17th electron of in potassium. So where is the then we have the subcell. So that is like a pin code of that particular city. So here also ISD or STD coding is there. So coding represents 3s2. So that is the atomic orbital and that is present in the third shell. Third shell, the period number 3, and subcell is the S. And then S cell, subcell, then they have the atomic orbital. And after atomic orbital, the electrons are there. So principal, azimuthal, magnetic, and spin quantum number. So that's why we can say that particular uh, electron is present there. The situation in that particular case. If suppose train is there, so we can how we can find out the bogie number 5. So that is bogie number 5 is there, their situation. Where is that in whole train? So in any of the atom, we can give certain numbers to those electrons, whatever all electrons. If suppose we have the 11 electrons in sodium case, so therefore the quantum number itself can gives the answer to the where is the fifth electron in sodium, which cell there is the present. So whole of the electronic configuration, and this electronic configuration represents what do they the representation. Then here in case of the alkali metal, the general electronic configuration of alkali metal is ns1, s atomic orbital, s subcell. Okay, so 3s1. So in this particular case, quantum number will be what? Principal quantum number is the 3. 3 represents. Then azimuthal quantum number, that is the subcell. Here the subcell itself is 0. And then we have the magnetic quantum number, that is also 0. So we get the 3s1. But here also the spin quantum number. Spin quantum number is of the either the rotation, the when electron moves like that, and that will be the positive half. So let's we have to discuss about all those particular alkali metals. Now we can continue with the, so here we can get what are the alkali metals. Here what we have already discussed the periodic table. Here the alkali metals are in the group number 1 and group number 1. Then the periods in case of the alkali metals, different periods are there. In period 1, that is the hydrogen. So hydrogen is not the metal, so that can be separate. But when we have to come down from top to down in a group, then we have this lithium. So lithium having the atomic number 3. So this lithium is present in period number 2, group number 1. Then we have the sodium. So sodium having the 11 electrons, and those 11 electrons are represents the sodium. Here the group is the same, group number 1, but period is the 3. So here the group period number is the 3. Similarly, we have the potassium. So those are the 6. Now we can come back to the atomic structure. That is also relevant with the alkali metal. So atomic structure explains what are those particular the number of electron and how those electrons are arranged. So structure of an atom, how those particular electrons represents the alkali metal, and how they are situated, how they are move their own orbits. So before that, we can discuss about the atomic orbital. So atomic orbital, I have one of the video lecture in case of the atomic orbitals, so that you can see that particular video lecture. So atomic orbitals, orbits. Where is the orbit? In the solar system, planet, our planet, Earth, having the orbit similar to that. Here in electrons, there is also the orbits, and where the electrons moves. But more thing is there, whether the we can give answer, uh, the Earth itself is stable. Where is the position of the Earth? So anyone can give the answer. The Earth continuously moving, and how this moves, how this rotates. So first of all, within one day, 24 hours, this rotates and continuously uh, moves in their respective orbit. One more thing is there. Is there any possibility the Earth can move in the Venus orbit? Venus orbit, not possible. So therefore, in an atomic structure, their respective electrons are arranged in their respective orbits, in their respective subcell, in their shell. And if suppose those electron moves from one orbit to another, that is the energy concern. And that can be whatever we can say, that is the spectrum is obtained in energy. Electron is moving from one shell, one orbit to another. So in case of the alkali metal, here is the only very simple concept, because in outer shell only one electron is there. So therefore, they have the specific property of alkali metal. And what will be the specific property uh, this alkali metal? Because here only one electron is there. The specific property is there. This one electron can be easily lost. And when electron is transferred from the alkali metal easily, that is the ionization energy. So in case of that, why electron is transferred, completely transferred? Because of the electronic structure. So electronic structure, electronic arrangement, electronic configuration, electrons ka arrangement is the most important concern in the alkali metal. So that can explain simple thing. So therefore, alkali metals are very active. Reactive metals, because easily lost one electron. So when we have to talk about the reactivity of these elements, sodium reactive, potassium more reactive, rubidium, cesium, francium, more and more reactive. Cesium itself is one of the uh, we have the timing. So that is the cesium watch. So the time constraint, whatever that particular thing, so there is the role of those cesium, and then. So what we have, the concern of all those metals which are arranged in a specific order, and these are the alkali metals. So now we have to other one structure we have discussed. The groups we have already discussed: alkali metal group and lithium, then the sodium, potassium, rubidium, cesium, francium. These are the different examples. So lithium itself, sodium, they can readily form. So here is the electronic configuration table, and this can represents whatever, this is the whole periodic table. And here you can see the group number 1, group number 2, group number 3, and group number 4. But all those are not towards the So group number 1 is the is one of the, but we have the lithium. So electronic configuration of lithium, this one is the 2s1. So 2s1 directly represents here only one electron in outer shell, and this can be easily given out, and they form the different salts with the halogens. So halogens, whatever the relationship with alkali metals and halogen. So here group number 17, this group number 17 itself is the halogen. So that is the oxygen, and then we have the fluorine, then chlorine, then bromine, and then iodine. So simply these alkali metal, one electron is lost, and that electron easily that can be taken by the group number 17, and group number 17 is the halogens. So in case of the halogen, that is the fluorine, chlorine, bromine, iodine, astatine. So what we have, you can see the alkali metal from that side, group number 1 and group number 17, and they combine with each other. What will be the product? Those are the ionic compounds are obtained, because the alkali metal easily gives the positive ion and forms easily the cation. So sodium cation, and then potassium cation, lithium cation. Whereas the halogens take one electron and they form the anion. So whatever the electrostatic forces between the cation and anion, and form a very strong bond, and those are the ionic bond. So regarding the ionic bond video lecture, which I have, which is represented in the form of the ionic compounds, ionic bond. So ionic bonds are very strong. So why they are the strong? Because of the electrostatic forces between the cation and anion. So here, whatever the represents this group number 17, and what about the group number 16? So what products are formed with alkali metal? So alkali metal, if we have the sodium, sodium oxide. So what is the formula of the sodium oxide? Na2. Why Na2O? This one. So in case of the sodium fluoride, the chemical formula, the chemical name of NaF, that is sodium fluoride. And what about the oxygen? Sodium oxide. So in sulfur, the sodium sulfide, sodium chloride, so sodium bromide, sodium iodide. So respectively, we have to see why one oxygen is required with the 2 of sodium. This one can be explained because the sodium itself can easily lose one electron. After loss of one electron, what happened to the sodium positive? Because the octet is complete in that particular sodium cation. So therefore, no further remove from the that particular, because of the octet is complete. So therefore, we can't remove the second electron from the sodium cation. If we want to remove, then large amount of energy is required. So therefore, the first ionization potential of sodium is very low as compared with the second ionization potential. So here, whatever we have to see, that is the uh, alkali metals. 1s1, that is the hydrogen, 2s1 lithium, and then 3s1, that is of the sodium, and then 11, that is of the potassium, that is of 19, then rubidium having the 37, then cesium atomic number, then that can be represented 55, and last one 87. Here all these arrangement is of the S1. So specifically the spin quantum number of S1 is the plus half. All of you are well known about the quantum number. So the rotation, so the electron moves like clockwise because this is the first electron and there is no opposite electron is available. So therefore this electron can be easily removed. So that's we have the alkali metals example. Now we have one of the this is also the constant. The group number one, the here the sizes. So what about the size? Hydrogen that is whatever however that is in group number one, but hydrogen is not an metal. So therefore this is represented in group number one. So here lithium group number one, then the size is increased. The sodium and size is further increased, and that is the potassium. Then the rubidium, and lastly we get the cesium. So what we have? Orbits are increased, as well as the number of protons are also increased. So we have to see when atomic number is increased, so simultaneously their atomic number itself is increased. So what happened? The size is also increased because of the orbit's expansion, because of the shell expansion. So outer shell remains as such, but in case of the outer shell, only one electron, and that can be easily. So one more thing is there here, because the outer shell one electron is there. So these metals are also called electropositive. What is the meaning of the electropositive? Because they can easily form cations. They can easily loses the one electron. So therefore, these are the electropositive metals. If you know about the which are the electronegative, anyone can give the answer. Alkali metal electropositive. So this need also the electronegative. Which are the electronegative? Fluorine, chlorine, bromine. Simply, in case of the fluorine, it can take easily one electron. Why this can easily lose the electron and easily halogens take the electron. So that is big relationship between the alkali metals and halogens. The well-known example in our life, and that is the simple example, the table salt which we are using. All of have the use of the sodium chloride. So sodium chloride having the very great role. How? Because sodium chloride itself is formed by the strong acid and strong base. Strong acid, so you can also see my video lecture on the acid and bases. So in that particular case, strong acid and strong base. So here sodium chloride itself is formed and the neutralization reaction of acid and base, and then we get the sodium chloride. So here the question is there, electropositive and electronic both combined with each other. Electrostatic forces, heavy forces, and they combine formation of the ionic compound. And these ionic compounds are soluble in the water. So this is the representation. So why we can say that alkali metals having the electropositive, that can easily say, because the these represents easily losses one electron. And why easily losses? Because that is in the outer shell electron, and easily that can be gives easily. So therefore, here you can say alkali metals combined with the halogens. So get the alkali metal halides, the general formula. All of you are well known about the sodium iodide, the iodized salt. So that is the weight value of the iodine. So that is related with the different hormones. So iodized salt in which the iodine is added in the form of sodium iodide. So sodium and iodine. So here we can say one of the most important ones. If sodium relates with the chlorine, okay, then sodium cation will be there, not the sodium atom, sodium cation. This combined with chlorine and iron. So what happened in between the sodium cation is the size of the sodium cation is less than the sodium atom. So that become small sodium cation, and whereas the chlorine takes the electron, so that become the large. So here that is the electrostatic forces and formation of the ionic compound. So alkali metal forms ionic compounds with respect to the halogen. So this one represents now from where we get the nature occurrence. Well, no sodium carbonate with the, so there are the certain nitrates, the oxide, sodium oxide, potassium oxide. Alkali metals are the most reactive metals and thus do not occur in free state. They are in the form of the combined state. Alkali metals are the most reactive metals. Reactivity we have already discussed, and that is related with the electron, easily reactive. So alkali metals are most reactive. Even if suppose we want to put the sodium on our table, so that openly we can't put the sodium, as well as the more reactive itself is the potassium. So they do not occur in the free state. So what happen? They mostly occur in the form of halides. As we have discussed, sodium chloride, and even the role of the sodium chloride in our body. So that because when we have the medical science, and here the patients are given the saline water. Why they give the sodium chloride water? That is the saline water. That is represent 5% of sodium chloride is given to the patient, which in the medical the hospitals. So why they are giving? Anyone have the answer? Because this certainly concern, and this can whatever sodium cation and chlorine chloride ion both are responsible for this their uh, for activeness of the organs. Different organs represent the sodium chloride, and outer of the organ in our body that represents the potassium chloride. So both are important in our life, potassium chloride as well as sodium chloride. They mostly occur in the halide, borates, silicates, nitrates, and oxides. Some alkali metals occur abundantly in nature. Sodium is the seventh, and potassium is the eighth abundance elements. Now, whatever we have already discussed, more discussion have been done, taken, and the reactivity, the least reactive, sodium is the least reactive, and then we have the lithium, sodium, potassium, and finally, most reactive itself is the whatever the losses of one electron will be take. So here, this is the reactivity, and all the alkali metals have one valence electron. We have already discussed the NS1 outside the noble gas core. What about the noble gas core? That is the noble gas configuration, and those are noble gases. Uh, for example, helium, neon, argon, kryptons. So that particular electronic configuration occur if one electron is lost. So this in outermost valence shell of these elements make them the most electropositive metal. We have already discussed about the electropositive. They readily lose electron and they form the monovalent ion. This is the reason why they are never found in the fresh nature. Now, they are the size. We have already discussed about the alkali metal atoms have they are the largest size in a particular period of the periodic table, which increases in the atomic number. Then atomic and ionic radii of alkali metals also increase from moving down to the group from the application. So lithium itself is one of the application most important in the formation of the lithium alloys and then lithium carbonate. This is used in special kind of the glasses, lithium aluminum hydride. This is most one the reducing agent in the synthetic chemistry lithium aluminum hydride. So Li and aluminum, then H4, and this is one of the most important concern about that is used as a reducing agent and the synthetic chemistry. Along with this, sodium is used softening of hard water. That is the whatever all of you are well known about the sodium carbonate, and this is also used in the paint and dye. Sodium also in the paper and textile. So this is all about whatever. So now we can see the different queries. So how we can explain those particular queries. Is there removal of second electron difficult in alkaline? So the answer very difficult. Whatever we have discussed about the first ionization potential and the second ion, this is because of the inert gas configuration. Inert gas configuration where this is the explanation. The first ionization enthalpy of alkali metal is the lowest among the elements in their respective period and increases on moving down the group. The second ionization enthalpies of the alkali metals are very high because by releasing an electron, ion require noble gas configuration. So removal of second electron itself is difficult. So the correct answer is the A, where answer yes, no, maybe can say that is the answer number A. Yes, there is the removal of second electron is very difficult. So for example, sodium cation, then it is very difficult to get the sodium plus 2. Only sodium plus 1 is known, and so that particular. Now another question is related with the hydration. What about the hydration? I have discussed in our human beings, and that in the medical science, that is the use of the what is we are using in the that particular, that is the saline water, because the organs are hydrated, organs have the energy, organs have the activeness because of the sodium chloride. So sodium chloride, the 5% saline water is given to the different patients in the medical science. So because in that particular case, the sodium and chlorine, this one question is related. So the degree of hydration depends upon the size of the cation. So here the correct answer itself is the A. So you can explain where is the potassium chloride in our body, where is the sodium chloride in our body. So the correct answer, because the hydration, then the organs are become more active. That is because of the hydration. So hydration concerned, hydration itself is most important in our body. So what we have, the medical science uses the saline water. They are using and they continuously give the patient the drips. So whatever those particular drips contain 5% sodium chloride, and that is for the organs hydration. So because of the hydration, the organ remain healthy. So first of all, they are giving the that particular, and continuously they are giving the patient. So why? Whereas when we go to the potassium, so potassium itself have more hydration. So in our body, the centrally organs are related with the sodium chloride, whereas the potassium chloride, the outside of the organs in our body. So here the hydration. So whatever someone are using the potassium chloride salt for the purpose of their table salt, and however the usual itself is the sodium chloride, but in some cases the sodium iodide is also added. So that is because of the hormonal concern. Sodium iodide salt is present. So that's alkali metals have the great role in our life because they are directly related with the hydration. So how we can hydrate if we are happy with the hydration? So organs must be hydrated with the sodium and outer of the organ in our body, that is the space available, and that can be represented. So here the size of the protection is more. So therefore, the hydration will be more. So this is one of the good question. One of the, I think, the life question, and this is the life supporting, and that is. So here the answer is the A. The degree of hydration depends upon the size of the cation. Smaller the size of the cation, greater is the relative degree of hydration is an increasing order. So therefore, you can get this is the answer. Alkali metal shows first plus one oxidation state and their atomic volume down the group is irrelevant. So this one it decreases. So the correct answer is the C. Here the explanation: alkali metal atom shows only plus one oxidation state because of their unipositive ion at the time the stable noble gas configuration. The atomic volume of alkali metal is the highest in its period, goes on increasing down from group top to bottom. So here the decrease the atomic volume from the down in the group, and that is the next the question, that is which of the following is true regarding the reactivity order of alkali metal towards the hydrogen. The correct answer lithium, then the sodium, potassium, rubidium, and cesium. Explanation: 2 moles of alkali metal reacts with 1 mole of hydrogen molecule in order to form 2 moles of alkali metal hydride. So therefore, the correct order of reactivity of alkali metal is like that. So here another question: alkali metal dissolves in ammonia liquid, giving the blue solution. This is due to formation of ammoniated metal cation and electron. Ammoniated, so that's why they gave deep blue solution due to the formation of the ammonia. The metal cation and electrons. The blue color is due to oxidation of ammonia. Electron to the high energy level and the absorption of photon. It's in the red region of the spectrum. This one is another question. Sodium peroxide in that is in color, and potassium superoxide that is used in the source. Here the correct answer is yellow, and the oxygen super used in the source of the, so potassium superoxide is the source of the oxygen. So that can get better, and potassium superoxide is used as a source of oxygen in submarine space shuttle and in emergency breathing apparatus such as oxygen mask. So lithium fluoride, that is whatever the answer is the insoluble in water. Allied absent lithium. However, some other soluble. This is because lithium fluoride is soluble in non-polar solvent and has a strong covalent bond. Lithium fluoride is represented by the formula. So thanks for all, and whatever we have discussed, the different alkali metals. So those particular alkali metals and their characteristics, so we can get relevant information. And most one, I am again giving that chemistry itself is most relevant in our life, and that is because we have seen a number of those alkali metals are used in our life: sodium chloride, sodium iodide, sodium potassium iodide, and as well as they are strong ionic compounds. Whatever the strong bond is there in between the alkali metal and halogen, then they form with different compounds with the non-metal and non-metals, whatever the represented in the P block elements, that is the oxide, that is the sulfide, then the halogens, whatever the nitride, nitrogen also, lithium nitride itself is so lithium can react with the nitrogen. So let's we have concludes that alkali metals represents most of the whatever the chemistry is most important relevant in our life, as well as they have applied in various applications, whatever the space application, potassium superoxide is used. So that is all about. If anyone have the question regarding this, so he or she can mail me, and he or she can directly get answered by the mobile phone, as well as you all are requested to like this particular video, as well as the Suresh Gyanviar University, which have number of different courses available, and Suresh Gyanviar University is one of the international university. So all of you are welcome to that particular Suresh Gyanviar University. Okay, all the best. So this I feel you got the most relevant information. So all of the all of the best. Okay, all the best for all.